Now, Catherine is mad at Daniel for hitting her on the bumper cars. So she wants to run and tackle him. So here's Catherine. And then here is Daniel. So let's say Daniel is walking at a speed of v d1. Catherine is running at a speed of v c1. Catherine hits Daniel, and they stick together and continue moving forward. So if we're given mass of Catherine, velocity of Catherine, mass of Daniel, and initial velocity of Daniel, we need to find velocities after collision. So Catherine runs at Daniel and tackles him. They stick together. So this means coefficient of restitution equals 0. All right, so let's say mass of Catherine is 40 kilograms. And velocity of Catherine, to start with, is 3 meters per second. Now Daniel is walking at 1 meter per second, and his mass is 60 kilograms. So to find their post-collision velocities, we know that there's no external forces here, so momentum must be conserved. So we'll write that equation. Mass of Catherine times initial velocity of Catherine plus mass of Daniel times initial velocity of Daniel equals the final velocity. So since they stick together, we know that VC2 equals VD2 because they stick together in a plastic collision. So here we can write that this is V2 times mass of Catherine plus mass of Daniel. Now in this case, there's only one unknown. So we don't need the E equation, but E equals 0, so it's not gonna be helpful anyway. So now we just put in the numbers. We'll have 40 times, actually we need to say positive X this way because that is line of impact. So 40 times 3 plus 60 times 1 equals V2 times 40 plus 60. 120 plus 60 equals 180 equals 100 V2, 1.8 meters per second equals V2. And this is to the right. So to recap, we were given initial masses and velocities and told that this is a plastic collision. So then we know that since there are no external forces, momentum is conserved. And since it is a plastic collision, final velocities are the same. So we just wrote out conservation of momentum, plugged in the numbers, and solved for the unknown velocity.